This is Unit 3, Lesson 3, Systems and Elimination. And our objective is students will be able to solve a system of equations using elimination. So what is elimination? Elimination is a method for solving systems of equations where you add and subtract equations to eliminate one variable. So when we're solving with elimination, we're either getting rid of x or y, or whatever variables you're using, you're getting rid of one of them and then solving for the other. We're going to go through 3 different examples and the steps for how to do this. Our system of equations is 2x minus 3y equals 8 and 4x plus 3y equals negative 2. The first thing I need to do is line up the like terms. Sometimes you'll have to rearrange your equations. Sometimes it will already be lined up. Right now, if you look over here, we have 2x and 4x. They're both x terms lined up. Negative 3y, positive 3y are lined up. The equal signs are lined up, and then the constants 8 and negative 2 are lined up. Now we're going to move on, and we are going to eliminate terms with opposite coefficients. Well, what do I mean when I say eliminate terms with opposite coefficients? Remember, a coefficient is the number that is being multiplied by the variable. So, first term is 2x. The coefficient is 2. Negative 3y, the coefficient's negative 3. 8 does not have a coefficient because there's not a variable. On our second equation, we start off with a coefficient of 4, and then we have a coefficient of 3. If you look at our x terms, the coefficients are 2 and 4. On our y terms, we have negative 3 and positive 3. Those are opposites. They're the same number, but one is positive and one is negative. When I combine those together, negative 3y plus 3y would give me 0. So I have eliminated that. Now I need to combine everything else. So we'll combine 2x plus 4x, which is 6x. Bring down the equal sign. 8 minus 2 is 6. My third step is to solve for the remaining variable. So in order to solve, I need to use the division property of equality. And I find out that x is equal to just 1. Now we're at the same point that we would get to in a substitution problem. I need to take this x, my found value, and I need to substitute it back into either equation. It doesn't matter which equation you choose, so I'm just going to choose this first one, 2x minus 3y equals 8. So I have 2. Instead of x, I'm going to substitute a 1 minus 3y equals 8. Now I need to solve, and that is my 5th step. One thing you can pay attention to here to make sure you're not making a mistake is the variable that you're solving for. The first time I went through, I solved for x. If I was solving for x again, then that would be a good hint to me that I'm probably doing something wrong. But this time I'm solving for y. And I found out that y equals 2. And finally, we can't forget to write our answer as an ordered pair, x, y. So my solution is 1, 2. Let's quickly go through a couple more examples. So my system is 2x plus 3y equals negative 5, and negative 2x minus 2y equals 2. I need to line up my terms, make sure my x terms are lined up, my y terms are lined up, and my constants are lined up. Next, I need to eliminate terms with the opposite coefficient. Last time we eliminated y, but this time I see that I have a positive 2x and a negative 2x. Those are opposites. So we can go ahead and just cross those out and say that we are left with 3y minus 2y is 1y, or just y. Negative 5 plus 2 is 3. My third step is to solve for the remaining variable, but that's actually already done. I already know that y is just 3. So I can move on to the fourth step, substitute the found variable, y equals 3, into either equation. I'm going to choose that first equation, 2x plus 3y equals negative 5. I need to replace the y with a 3 because I just found out right here that y equals 3. 2x plus 6 equals negative, that's not a 6, 2x plus 9 equals negative 5. I subtract my 9 and find out 2x equals negative 14. And when I use the division property of equality, I find out that x equals negative 7. My x value is negative 7. My y value is 3. Now we're going to do one final example. 8x minus 2y equals 6. Negative 3x plus 2y equals 4. My x terms are lined up, y terms are lined up, equal signs lined up, and constants are lined up. Let's cross out the opposite terms. Negative 2y and positive 2y will equal 0. I'm left with 11x, not 11x, let's try that again. 8 minus 3, not 8 plus 3, is 5x equals 10. And when we divide, we find out x equals 5. Now I'm going to substitute 5 back into my first equation. 8x minus 2y equals 6. Instead of x, we have a 5. 40 minus 2y equals 6. Oh, I have made a mistake, haven't I? Let's go back and fix this. X does not equal 5. When we do 10 divided by 5, we get a 2. I'm sorry about that. Now let's substitute it the right way. 8x minus 2y equals 6. 8 times 2 minus 2y equals 6 gives me 16 minus 2y equals 6. We subtract our 16 and find out that negative 2y equals negative 10. And when we divide, we find out y equals positive 5. So my solution is a positive 2 and a positive 5.